All right, so in the first video, we covered the distance between a point and a plane, or the distance between two parallel planes, using the same premise. You just need a point and a normal vector, and you have the distance formula now to be able to figure that out. On this one, we're going to talk about the angle of intersection of two planes. So we're going to have to use the idea of normal vectors from each plane to diagram what this would look like. So I'm going to do my best to sketch what this would look like. This is not the easiest thing, so bear with me. So I'm going to have a plane which kind of looks like it's vertical. Again, let's see if I can do this correctly. And it's going to come down here to the point of intersection with another plane, and that's going to kind of be behind a plane. So now let me see if I can draw a second one here. Now I'm going to draw one that looks like it's intersecting here, but that'll be behind until here. It's going to be above here. Maybe something like this. Let's see if this is going to work. Oh, that line is horrible. All right, it's not the best, but it'll do. So right here would be like the intersection. As a matter of fact, let me put that in a different color. Right here would be the intersection of those two planes. So hopefully you can kind of see what that's doing there. I got two planes which are crisscrossing. And the idea is pretty basic. There's an angle in between these two planes. Okay, so if I go from the black plane down to the green plane, there is some kind of an angle there. And technically, there's another angle over here in between on the other side. Hopefully you realize that those things are going to be, and I don't want to call that theta because they're not both theta. These things are going to be supplemental to each other, meaning they add up to 180. So there are actually two angles there. Either one of them technically is correct. I think we're usually going to go with the acute angle or the smallest one, but either way, you're going to be able to find both. So again, the idea is if I were to take a normal vector from the black plane, well, the normal vector is perpendicular, so it's going to look something like that. And we'll call this the normal vector for 1. And then you're going to have a normal vector. I'm running out of colors. Then you're going to have a normal vector, which is coming off of the green plane, which is going to look something like this. That does not look normal. Maybe something like that. And we'll call that the normal vector for 2, for the green one. So the idea is if I have those two normal vectors, which kind of create the, well, not create, but we can get those two normal vectors by looking at the equation of a plane. Remember that you can move vectors anywhere. So if I were to extend the purple vector out to like right there and then redraw it, and then I were to extend the blue vector out to right here and then redraw it, so now that's normal 1. And this one's normal 2. What you can see is the angle in between them is the acute angle. And that is the angle between the two normal vectors, and by virtue, that angle is going to be exactly the same angle as the angle between the planes, because those normal vectors are perpendicular to the planes, so the angle between the normal vectors is going to be the same as the angle between the planes. And as a matter of fact, this angle right here is really that one right there. It's going to be the acute angle in this case, just kind of visually. So we can write this up and say there is an angle between N1 and N2. Both are exactly 90 degrees from their respective planes, meaning the angle between them is equal to the angle between the planes. All right, let me see if I can do this. I'm not sure. I'm going to try. Let's see. No, it's not what I wanted to do. Okay, not working. All right, I was trying to make a copy of that graph there, but I'll just have to come back up to it and reference it later since it does not seem to be working for me. All right, well, let's go ahead and do example 1, or sorry, excuse me, example 3, first example of this video. Determine if the planes given by x plus 4y minus 3z equals 1 and negative 3x plus 6y plus 7z equals 0 are parallel, perpendicular, or neither. And if they are neither, find the angle in between them. So the easiest thing to do, first of all, each one of them, again, is associated, has a normal vector to it. So let's go ahead and write, do this one in blue. So this will be n1. That's going to be 1, 4, negative 3. And then n2 will be negative 3, 6, 7. So if these two planes are parallel to each other, that means that the normal vectors would also have to be parallel. And remember, the easiest way to determine if vectors are parallel is if they are constant multiples of each other. So I'm not really going to write this part out, but the easiest thing to do is, okay, say, look at the x value in n1, look at the x value in n2. To get from n1 to n2, I would have to multiply the x by negative 3. But if I multiply the 4 in n1 by negative 3 for the y component, I do not get the correct part in the y component in n2. It would have to be a negative 12, and it's a 6. So they're not parallel. So we can just easily say, not parallel, normals are not constant multiples. Okay, that's the easiest check. Just check to see if something times one of your vectors gives you the other vector. If that's not the case, they're not parallel. To be perpendicular, well, we have an easy way for something to be perpendicular. It's going to come back to our formula that n1 dotted with n2 would equal magnitude n1, magnitude n2, cosine of the angle in between. And to be perpendicular, we know that the dot product has to be 0. So let's check to see if the dot product has to be 0 or is 0. So if we do n1 dot n2, you're going to get negative 3 plus 24 minus 21. Lo and behold, that is going to equal 0. So it really doesn't make any difference what the magnitudes are in this case, because we know that the left side is going to equal 0. So these really don't matter. All that's going to matter is that we know that 0 equals whatever that thing is, because remember, no matter what the magnitudes are, we would divide them on both sides. It would still be 0. And theta is going to be 90 degrees. So this means perpendicular. Trying to erase a little bit here. It's not letting me do it. There we go. Perpendicular. And then obviously if both of those fail, then you'll just use this formula right here to find the angle in between them. Because the left side wouldn't be 0. You'd have to then find the magnitudes, and then you could find theta. All right, so let's move on to example 4. So once again, I've got two planes. We want to determine if they're parallel, perpendicular, or neither. And if they are neither, we'll find the angle in between. So we've got N1 is 1, 1, 1. N2 is 1, negative 1, 1. You should be able to take a look at those real easily and figure out they're not constant multiples, so they're not parallel. Let's find out if they're perpendicular. So we're going to do N1 dot N2 equals magnitude N1, magnitude N2, cosine of theta. So the dot product is going to give us 1 minus 1 plus 1. Well, okay, so that's definitely going to be 1, so it's not 0. So now we actually have to find the magnitude. So the magnitude of N1 is going to be the square root of 3. They probably handle that one pretty easily. Magnitude of N2 is also going to be the square root of 3 times the cosine of theta. So square root of 3 times square root of 3 is 3. So it looks like we're going to get the cosine of theta is a third, or theta is going to equal the inverse cosine of 1/3. And again, we're just going to deal with the acute angle that this gives us. So if you plug that in your calculator, you're going to get 70.53 degrees or so. And that's the acute angle in between the two planes. Obviously, you could do the supplemental angle and it'd be like, what was that, like 109.47 or something like that. But the acute angle is the one that we're going to look for. All right, one more type of thing. Now we want to find the line of intersection. This is kind of where I'm going to have to go back up to that other drawing on the previous page. So if I want to find the line of intersection of two planes, so obviously two planes can cross, and when they cross, it's going to cross and it's going to form an infinite line. I mean, that makes, hopefully should make sense, because planes go on forever, the line goes on forever if they cross. So in order to do that, what we need is we need one point on the line and a parallel vector. Because remember, to write the equation of a line, you need a point and a vector. So in order for us to find a point on the line of intersection, well, typically the way you find if things intersect is you set them equal to each other. Not an easy thing to do in this case, because in this case you would get two equations with three unknowns. However, we can still find one specific point. So the idea is this. We're going to let, and you could do this with any variable, just in this case, we're going to let z equal 0, just because that's the one I chose. So if z is 0, what I get is I get the equations x plus y equals 1 and x minus y equals 1. And that comes from the two different planes, letting z equal 0. So now what we can do is we can actually do our linear combinations here. And we're going to get that 2x equals 2, adding those two things together. So that means x equals 1. And if x equals 1, we're going to do a little bit of a back substitution. We'll plug 1 into, it doesn't really matter which one, but we'll plug 1 into this one right here for x. And that means that y also happens to equal 0. Doesn't usually quite work out that well. A lot of times these numbers are messy. But now we have a point of intersection, or at least one point on the line of intersection, I should say. So what we've got is we've got the point 1, 0, 0. That's a point on the line of intersection. Now what we need is a parallel vector, and this is where I'm going to go back to the drawing on the previous page. Taking a look at this specific sketch right here, if I had those two normal vectors, n1 and n2, and I were to cross n1 and n2, what I'm going to get is I'm going to get a vector which is perpendicular to both. So if you can kind of visualize that, I'm going to get a vector which is perpendicular to both of these vectors, so like off in that direction, but it's going to be something which is perpendicular there, but also perpendicular there. If you can think about that, what you really get, because remember you can move the vector anyway, anywhere, is a vector which is like this. It will be perpendicular to both, which means it's going to lie, or it can lie, on the line of intersection. So it will be a parallel vector. So I did not draw the one up at the top very well. But that's exactly what you're going to get. If you cross n1 and n2, you'll get a perpendicular vector, which is going to be parallel to that line of intersection. So what I need now is the cross product of n1 and n2. So let's do the cross. So I, J, K. N1 we're going to call 1, 1, 1. N2 we'll call 1, negative 1, 1. So let's see the cross product. If I eliminate the I row and column, I get 1 minus negative 1, which is 2. Eliminating the J row and column, we're going to get 1 minus 1, which is 0. Don't forget to change the sign for anything other than 0, obviously. And then if you eliminate the K row and column, you're going to get negative 1 minus 1, so that's negative 2. So this is N1 cross N2, and that's going to be the perpendicular, excuse me, the parallel vector that we need to write the line. So this is our parallel vector. So now we have a parallel vector, we have a point, we can write the equation of the line. So X is going to start at 1, and the vector tells me it's going to increase by 2. Y is going to start at 0, so I don't need to write that, and it's going to stay at 0, so it's really just 0. And then Z is going to start at 0, but it's going to decrease by 2, and this is the equation of your line of intersection. All right, one more. So now we just want to find the symmetric equations for the line of intersection of the two planes. So basically we just have to solve these things for t at the end. So let's go ahead and do the same general idea. We're going to start off by finding our point. So we're going to let, not x in this case, I want to let z equal 0. And there's really no better choice usually in most of these cases, but you can pick whatever letter works easiest for you. So that'll give me 3x minus 4y equals 6. Now in this case, we can't just do the straight linear combination. I can choose to multiply the entire top equation by 4 or by negative 3, and it'll get rid of one of the variables. Or I could solve the top equation for x or y and then do a substitution. It's really completely up to you. I'm going to go ahead and multiply the entire thing on the top by 4, and then we're going to add down. I'm doing that kind of in one step. So that'll be 4x on top plus the 3x is 7x. It's going to give me 4y minus 4y. That's gone. And then it's going to give me 8 plus 6, which is 14. So x here is going to equal 2. If x equals 2, plugging it into the top equation, y is going to be 0. So my point is 2, 0, 0. Again, really nice that I'm getting a couple of zeros out of these things. That's not always going to be the case. All right, now we need the cross because I need a parallel vector. So let's cross. Let's go and do it in blue this time. So let's cross 1, 1, negative 1, and 3, negative 4, 5. And let's see what we get there. Eliminating the I row and column, I'm going to get 5 minus positive 4, so that's 1. The J part is going to give me 5 minus negative 3, so that's 8, but we changed the sign. And then the K is going to give me negative 4 minus 3, so that's negative 7. So there is our parallel vector. Let's go ahead and write these in our standard form of a line first, our parametric form. So we're going to get that x starts at 2 and increases by 1. Y starts at 0 but decreases by 8. And Z also starts at 0 but decreases by 7. So now to write these in symmetric form, we solve each one for t. So it looks like we're going to get x minus 2 equals y over negative 8 equals z over negative 7. And there you go. Just a little over 20 minutes. Plenty enough to get your homework done. Just be careful.